Okay, well, happy Friday, everybody. It's week 3 Friday, and I appreciate you being here. And and I appreciate those of you, especially who have your cameras on. And again, if you're willing to have your cameras on, it makes me happy. So I appreciate you guys being here. It's I think we have around 80 students enrolled, but and already it's only the third week. We're not even like 1/3 of the way through the quarter. Or are we exactly 1/3 of the way? No, not quite. But as you can see, just with those who've logged into class, the numbers are dropping off a tiny bit. And well, I hope um, I get it. I get it. I was a student too, so I understand that sometimes it's difficult to make it to class. Before I get started with the lecture content, let's talk about coming back in person and what that's going to look like and stuff. Okay, so the university released some guidance, and my understanding is that they encourage classes to be in person, but they left it up to kind of the professor's discretion as far as what we're going to do. So I've decided starting Monday, January 31, so that's the first day back after January 28th, I will start teaching the class in person. Okay, so I'm going to come to campus and I'll be teaching in the classroom. And I forget where we are, but I think we're in Dodd or something. Well, anyway, I'll be on campus and I'll be teaching the class in person. Okay. I will continue to record my lectures. I will continue to post them online. All right. And when I record the lectures, I have some screen recording software, and so I'll be recording my lectures that way. It will not be a live kind of simultaneous broadcast over Zoom or something like that. Okay. If you want to, if you want to be live, you kind of have to be in person. But if you're okay with watching a video, then you can watch a video after the fact. So, but I will record the video, and I will upload it. It's just it's not going to be over Zoom. Okay. And I'll continue to use view quizzes. And so if you can't attend in person or live or whatever, just watch the video later, and you can answer your questions, and you'll still get credit for, it's not attendance, but you'll get credit for, the view quiz thing. Okay. And of course, if you're in person, you got to follow all of the rules and, health and safety protocols, as outlined by the university, which means medical grade mask, N95 mask or something. You have to fill out your symptom monitoring survey, and, like no food or drink in class and things like that. Okay. Kind of the most complicated issue here is how we're going to do our exams. So we have a midterm exam scheduled for week 6, and I intend to still hold an exam on that day. I think it's February 9th. Don't quote me on that, but I think that's what I have written in the syllabus. And my hope, okay, and maybe I'll just do a quick poll. And I did a quick poll the last session at 10 o'clock. My hope is that most of the students, like 90% of students or something, will come to class in person, and we'll take the midterm exam in person. We'll take our exams in person. And if the student is not comfortable being in a large classroom with other students and stuff like that, I'm willing to make accommodations to kind of allow the student to take the exam in my office, where it's much less crowded, or much fewer people. We can schedule different times for that, or a student can schedule an exam with CAE to kind of have these different settings for the exam, and then only and I will also have a remote option for kind of exceptional cases. So these would be kind of cases where students absolutely cannot come back to campus, maybe maybe they live, far away in another country or something and can't travel back to campus or something like that. And the intention is that this remote exam thing is going to be kind of the exception, with only a very, very, very few number of students doing the remote exam. But and the reason why I say this is because I think it's important that we have kind of this in-person written exam. I didn't get to do this last year because it was all remote, and I feel like the students missed out on something, and they missed out on an exam. What are you talking about? So by nature of us being in person, or by nature of us taking an exam remotely, the nature of the exam is different. Okay, when I have an in-person exam, the questions in the in-person exam and the studying that you have to do for an in-person exam train your ability to read code. Okay, that's what I'm basically testing in an in-person exam. I will have code written out, and I'm going to ask you, like, what is this code going to produce? Is this code going to produce an error? What happens, after this code runs? What's the value of this variable, type of thing? And it tests the ability of you to be able to read the code, follow along, and know what's going to happen. All right, and that's a very, very important skill, because when you are trying to debug, you're trying to understand what's happening, you've got to be able to read code, either read your own code, read someone else's code, and understand what's going to happen, right? Without having to, copy and paste each line by line. I can't do that with a remote exam. By nature, with a remote exam, the student's taking the exam on the computer, and so they're going to have access to R, they're going to have access to the internet, they're going to have access to a bunch of stuff. And so if I ask a question, what is this line, what are these lines of code going to produce? I don't really have a way to enforce students not from using R on their computer. And so if a student doesn't know what the code's going to produce, they can easily just kind of copy and paste it into R and get the answer. And that's not really a test. That's just, can you copy and paste or retype the code or something like that. So just by nature, a remote exam, can't test the same things that an in-person exam tests. So, my preference is that, almost everyone takes the in-person exam. And again, I will, allow for exceptions. And if a student, truly can't come back to campus or something, we can make arrangements for a remote exam. So, maybe just kind of to gauge where you as a student body are, or at least in this class are, maybe I can get a couple reactions. And so if you're planning on coming back to campus for the reactions, give me a thumbs up. If you are absolutely not going to come back to campus at all, give me a red X. Okay, if you're absolutely not coming back to campus, give me a red X. And if you're not sure, if you're kind of debating about it, give me like the coffee symbol or something like that. Give me the coffee symbol if you're not quite sure. Okay. All right, so I see a lot of thumbs up. I see a lot of thumbs up, and I see a handful of coffees, and I got no red X's. I have like surprised eyes. I don't know what that means, but okay. That was kind of in line with the other class. The vast majority said they will return to be in person. A handful gave me, a small handful gave me coffee mugs, and we'll get in discussion. You can come and reach out to me and talk about how this is going to go. And again, if you're concerned about being in a classroom with other people, I'm happy to allow you to take the in-person exam in kind of like my office or the faculty lounge where it will be less crowded. And if that's reassuring to you, I'm happy to make that arrangement. And then again, if you're absolutely not going to come to campus or something like that, we'll try to do that. And so again, as I'm trying to be flexible and allow and accommodating for these different situations. But I don't. I guess one thing is I don't want students complaining that people are getting different exams here, and it's just not possible to create an online exam that's exactly equivalent to an in-person exam. Just the fact that there's two forms here means there's going to be different things happening. It's not my intention to make one exam like much harder than the other, but they are definitely testing different skills, right? One is your ability. So the remote exam, again, I can't test reading ability. So it's kind of be like a homework assignment where I give you stuff and you have to write code, except it's just going to be under a time crunch where you have to like write all of your code within, the allotted time. And that's that can be a stressful thing, but it tests different skills, and I hope you understand that just by the nature of having these different forms, that's what's going to happen. But anyway, that's the plan. So starting Monday, January 31, I will be in person. I will be teaching the class in person. I'll be recording, and I'll post the video for anybody who did not attend in person. Okay, any questions about kind of the current plan for, I guess, the rest of the quarter? Obviously, next week is we're still remote, but yeah, that will be it. Okay, all right, let's go ahead. I think my screen is still shared. Let's take a look at what we have planned for today. So today is we're looking at tidy data, and we're going to be looking at packages at this package tidyr, which is part of the tidyverse. And so this is Hadley Wickham and Garrett Grollman are the authors of this textbook, and I highly recommend that you read it. And you can actually read the entire textbook for free online. Okay, you can read the entire textbook for free online. And if you want the paper version, you can also purchase it at any bookstore. You can click this and buy the paper version for apparently $32. Okay, right now as of this moment. But great, it's a great resource. Hadley Wickham is actually kind of the primary author, one of the main contributors to the tidyverse, which is a set of packages that we use frequently, and I strongly recommend it. Okay, so the tidyverse describes itself as an opinionated collection of R packages designed for data science. All of the packages share an underlying design philosophy, grammar, and data structures. And included in the tidyverse are ggplot, Tibble, tidyr, dplyr, reader, per, stringer, and forcats. And in our class, we'll cover almost all of these with the exception of per and forcats. So we've already seen reader. And today we will look at Tibble and tidyr. And then in the future lectures, we'll look at dplyr. We'll also look at stringer and a little bit of ggplot. So so that's what we've got going on. Okay. Let's talk about Tibbles. So the package Tibble gives kind of the data structure that is most frequently used in the tidyverse. Okay, so a Tibble is a data frame. Okay, a Tibble is a data frame, but it tweaks some of the behaviors of data frames that make our life easier. And in fact, the R base core team, so that the people who are in charge of updating R itself, have actually taken into consideration some of the changes made by Tibble, but overall, the R core team and base R updates updates are very kind of cautious, and they try not to make huge drastic changes. Okay, and so if anytime you make a change to base R, it might break some existing code, and so it's so they don't make frequent changes to base R. Whereas packages like the tidyverse, those are very responsive and they update frequently. And one kind of drawback of using the tidyverse is that code you wrote 2 years ago. Okay, you might have written some code using the tidyverse, and 2 years later, when you try to run that exact same code, it no longer works because they've made changes with how some of these functions and operations, or they might have deprecated some of the functions and things like that. So that's something that could happen with the tidyverse. But overall, I think the tidyverse is absolutely excellent. And as data science evolves and new kinds of forms of data emerge and stuff, the tidyverse seems to be very responsive to the community and the field. So I think it's great. Here's what a Tibble might look like when you create it. Okay, so when you make a data frame, you do Data.Frame, and instead for Tibble, we just do Tibble. Okay, and here I'm just creating a Tibble with 1,000 rows. 1 E3 is 10 to the third. 1,000 rows. I'm asking for 1,000 random values. And here we're going to take the moment right now, add some arbitrary number to it. We're going to take today, add some arbitrary number of days to it. Just the numbers 1 through 1,000. We're going to do the random values. We'll sample some random letters, and I've got 5 columns: A, B, C, D, and E. And when you print out the Tibble, this is what it looks like. Okay, I got columns A, B, C, D, and E. And you'll notice when I print it out, it just shows the first 10 rows. Okay, and that's the default behavior of a Tibble, is that it just kind of shows, I think, the first 10 rows. Whereas, I don't know if you've ever had the experience while you're working in R, you just want to kind of check up on a data frame. So you type in the name of the data frame, and then when you hit enter, it's like that data frame has like thousands of rows, and like it tries to print the entire data frame into your console, and it just kind of blows up your console, and it's just like all the rows of the data frame, and you go, oh no, I want to look at my older lines of code, and you have to like scroll back, what feels like for ages to kind of get back to those lines. And if there were a whole bunch of columns, each line takes up like several lines on the console and things like that. So Tibbles are aware of the size of the console, and will only print columns that will fit, and will only print 10 rows at a time, which is a nice thing that happens there. Okay. A couple other things that are different when you work with Tibbles is when you subset a Tibble. Okay, when you subset a Tibble with a single square bracket, the Tibble will always return another Tibble. So even if you subset it to just one row or one column, okay, so if I do Tibble and I subset to the first column, I do blank comma 1, this is going to give me back the first column, it remains a Tibble. Whereas if we did this with a data frame and you subset to just kind of the first column, it's going to simplify to a vector, right? If you want the Tibble to simplify to a vector, you can do that, but you have to explicitly mention comma drop equals true. So you put in drop equals true, and it will simplify it to a vector. But as far as this thing goes, whenever you subset a Tibble with single square brackets, it will remain a Tibble. If you use double square brackets or you use the $ notation, that's when it will do the simplification. And this works the same way as data frames. So using double square brackets will simplify to a vector. Using the $ notation will simplify to to a vector, and that's nice. Okay, here's the difference with a data frame. When you use a single square bracket and you pull out one column, it simplifies to a vector. But if you use a data frame and you have a single square bracket, but you pull out two columns, then it remains a data frame. So the form of the data frame changes depending on how many columns you're extracting. It'll either remain a data frame or it will turn into a vector. And Tibble just says, you know what? I don't like that it changes whether I'm pulling out one column or two columns. We're always going to return a Tibble, and that's what it does. Okay. Whereas over here, you can only pull out one item at a time. You can only pull out one thing with double square brackets. You can only get one thing with the $sign notation. So that way, it will always return a vector. Okay, creating a Tibble. I've already showed you how to create a Tibble, but here I'm going to create a Tibble with 3 columns, A, B, and C. And you just kind of do it the same way you create a data frame. You can also take an existing data frame and just throw it into the function Tibble. And now it's a Tibble, okay? Which again is a data frame with just a few nice features, right? It's a few nice features. There's also a function called Tibble, okay? Tibble, which is Tibble row-wise, okay? A row-wise Tibble. And that is, if you're trying to input the data into R, perhaps you want to enter it row-wise. Now, R's default behavior when you create data frames and Tibbles and stuff is to do it column-wise, right? You name the column, you say what's going to go into the column. You name the column, you say what's going to go into the column. With a Tibble, you can basically write it out as a row. So it's helpful if you're like copying and pasting from like a web page into R or something like that. You might use something like a Tibble, or if you're just trying to quickly create a Tibble here. Have I given you any view quiz answers yet? Not yet, right? Okay. Today's first view quiz answer is the letter E. E as in elephant. E as in elephant is today's first view quiz answer. Okay. The philosophy of the tidyverse. I think we often present that data should be presented this way in our intro stats classes, but we say, every column is its own variable, and basically every variable has its own column. Every row in your data is an observation, and each observation just has one row. And every cell will have just one value in it. And that would effectively make your data tidy. So let's take a look at some examples of tidy data and maybe not so tidy data. So here is a small data frame or small Tibble of storms. Okay, we got tropical storms, we got the name of the storm, the wind speed, the pressure, and the date of the storm. And we see that this is tidy. Each storm is an observation, and each observation gets one row. Okay, each row is one observation. Each column is a variable, each variable gets one column. And so our variables are the storm name, the wind speed, the pressure, and the date. Here is maybe some data that is not tidy. All right, so what do we have here? This is, I think, cases of a disease. What are our observations? What are the values that we're recording here? And what are the variables? Okay, so we have countries. We've got one of the variables is the country, France. DE is Germany, Deutschland, not Denmark. Okay, DE would be Germany and US. Okay, and then we get the values: 7,000, 6,900, 7,000. And we have the year that this happened: 2011, 2012, 2013. So our variables are the country, the year in which it happened, and the count. Okay, And so we actually have three columns and a bunch of observations. So this is arranged kind of in this form, which is, maybe not what we want. All right, here's another example. And here we've got a table of, I guess, pollution, air pollution. And what do we have? We have the city, we have the particle size, we have the amount. But take a look at this. So we say, well, we got three columns and things like that. But how many observations do we have? Okay. Now, when we look at this and we can say, well, we've got 6 rows. That means we have 6 observations. And that is not wrong. But it might also make a little bit more sense to say, well, how many observations do we have? And there's really just 3 cities. We've got New York, London, and Beijing. So maybe our data should be arranged so that each city has 1 row. And if we're going to arrange it so that each city has just 1 row, New York, London, Beijing, what are the appropriate columns to have? Well, in that case, the appropriate columns would be the city name, and then the amount of large particles and the amount of small particles. And how is our data stored? Well, the amount of large particles show up in the same column here, every other row, and the amount of small particles also in the same column, just every other row. Okay, but these would be the variables: the city name, the amount of large particles, and the amount of small particles. So, this page is just reading in the data. The data is available on GitHub as these CSVs. So I'm just reading these in using read_CSV, and it's reading them in. Okay, and so here's the tidy data. And when your data is tidy, you can do vectorized operations with R. So, for example, let's say we wanted to calculate the ratio between the wind speed and the air pressure. Okay, we can just do storms $pressure divided by storms $wind, and it's going to be, I'm sorry, the air pressure divided by the wind speed. We're calculating the ratio between these two things. And R will do vectorized operations. It's for this first entry, it's going to do 1007 divided by 110 is 9.15. 1009 divided by 45 is 22.4. 1005 divided by 65 is 15.5. So this is the nice thing about having tidy data, is you can kind of just take these columns, do vectorized operations, and you'll get your results. And it's going to go element wise down the thing. Okay. If your data is not tidy, it's hard to work with something like that. So let's take a look at this table of cases. Okay. And we're going to say the variables that we're working with are the country, the year, and the observation is going to be, or the value is going to be its count. So each observation here is basically a year, how many cases happened that year. So if we do this, what will be the dimensions of the resulting data? How many rows are we going to end up having if we rearrange, if we pivot our data, rearrange our data, so we have these columns, the country, the year, and the count. And basically each observation is, the particular, the number of cases for a country in a given year. How many rows are we going to have? How many columns? What do you guys think? Okay. Well, okay. All right. Thank you. Thank you for responding there. Yes, we're going to have 9 rows and 3 columns. So when we pivot and rearrange our data, each of these values are going to be considered an observation, and we're going to end up having 9 rows and 3 columns. We're going to have the country, the year, and the count, and we're going to have 9 rows. So we're going to have France in 2011, Germany in 2011, US in 2011, France in 2012, Germany in 2012, and the US in 2012. And each of these things, we're going to have 9 rows, 9 rows total. Okay, so how do we do something like this? How do we go from this table into something that looks like this? Okay, well, this is done using the function pivot longer. Pivot longer. It used to be called gather. Now they call it pivot longer. okay? And that's because we're taking our data, we're pivoting it or like rearranging it, and the resulting table is gonna end up looking longer, okay? So what do? We are in the original data, the values that the columns that we are combining are the columns 2011, 2012, and 2013. So we are saying combine, pivot the data in the columns 2011, 2012, and 2013. We specify the columns that we are going to pivot. And those values go into one column, and the column headings go into this column year, right? So we say the names, that is the column headings, 2011, 2012, 2013, go into a column. What are we going to call that thing? Here we're going to say we're going to call it year. All right, so 2011, 2012, 2013, these values got combined. They got pivoted into the column year. What about these values? 7,000, 6,900, 7,000. Where do those go? Okay, those get pivoted into a column called cases, right? And that's, we specify the names of the new columns here, year and cases, and we've pivoted our data longer. And indeed, we have a Tibble, 9 rows by 3 columns, and it looks like this. Okay, so so the details of the function are written here. One thing is you can use the colon notation, so you can specify I want to go from this column 2011 through the column 2013, and tidyr will recognize, oh, these are column headings, and we're going to get everything in between those 2 columns. Okay, this names to is a character string. We've called it year, and values to is cases. Those are just character strings. They are arbitrary. They can be whatever you want it to be. Year and cases make sense. I could have done year and n, and that would have made just as equal sense there. You can pick terrible names, and R will do it as well. And so I could have called the column when it happened, and values to called how many. Now, in general, you should never put spaces in your column names, because when you do, you got to use backticks, and it becomes a pain to reference it. But it's technically not against the law, so so you can do this, and that's what will happen. Okay, but this is arbitrary. So year and cases make sense. Year and n makes sense. When it happened is acceptable but not great, and how many also acceptable but not great. But they're just arbitrary things. Okay, what really only matters is just which columns are you combining them to. All right, so here's a question. What happens if I say I only want to pivot the columns 2012 and 2013? What's going to happen if I pivot the columns 2012 and 2013 only, and I don't include 2011 as a column I'm going to pivot? Okay, how many rows am I going to end up having, and what will be the columns that I end up having in this new table, right? So first of all, just, I don't know, in the chat you can write, how many rows do you think I'm going to end up having in this table? Okay, so we're getting 6 rows, and that's correct. We're going to get 6 rows. What are the column names I'm going to have? What do you guys think? Okay, the columns that we're going to end up having country, 2011, year, and cases. Okay, so we're going to have a column for country. So basically, the columns I didn't pivot will remain, country and 2011. I didn't pivot those 2 columns. And the countries I did pivot disappear and become the year and cases column. Okay, so I end up having 6 rows and 4 columns. Okay, so the columns that I don't pivot just get duplicated, right? So we pivoted these 2 columns into each other. 2012 and 2013 got pivoted. And so the columns that didn't get pivoted, those get duplicated. So France 7,000, France 7,000, Germany 5,800, Germany 5,800. And it feels strange that 2011 is getting duplicated, but R, or tidyr, has no context. It doesn't know 2011 represents a year and it's got the same values as everything else. It could have been country and capital, right? So it was France and Paris and Germany and Berlin and US and Washington or something like that. And then you'd say, oh yeah, we should duplicate that, right? Every row should say France, Paris, in the year 2012, 6900, and France, Paris in the year, whatever. Okay, it would make sense to do something like that, but and those would get duplicated. And here it's just any column that doesn't get pivoted are duplicated. What would happen if I try to pivot all the columns, country through 2013? By the way, you should not do this, okay? But if we did it, how many columns am I going to end up having? If I pivot all 4 columns, what will the resulting table have? How many columns will I end up having? Okay, R gets confused too. Okay, yeah. So first of all, when you do this, R does complain, okay? And it says, hey, you cannot combine character data with numeric data, all right? It complains about that, right? Because it's expecting things. So R actually tries to stop you from shooting yourself in the foot. And it says, hey, you've got character data, you've got numeric data, so it combines. But I'm going to say, you know what? I don't care. I'm going to do it anyway. So I'm going to convert everything into character and then combine it all, okay? So I convert everything into characters and then I can combine it. And then what do we end up having? We end up getting 12 rows and 2 columns, a column for name and a column for value. And the name, again, are the former column headings. So we had a column heading for country, column heading for 2011, column heading for 2012, column heading for 2013. The column headings all end up in the name, and then the values in that column heading, in our case, the values inside the column heading country were France, Germany, and the US. Those get put in to this column for value here. Okay, so that's what ends up happening. Obviously, this is not what you want to do, but technically we have pivoted the data. All right, let's keep going. Let's look at this pollution table. Let me give you your second view quiz answer. Second view quiz answer is B. B as in bear. B as in bear is your second view quiz answer. Okay, here's the pollution table. It's 6 by 3. And what we're saying is we want to pivot this, right? We want to pivot this so that each row gets its own observation. Each row gets its own observation. So when we do this, we will end up having just 3 rows, right? So when we pivot the data, so if we start off with this thing, 6 rows, 3 columns, and we pivot it, we're going to end up having 3 rows, 1 for New York, 1 for London, 1 for Beijing. And we're going to have 3 columns, 1 for the city name, 1 for the large particle amount, and 1 for the small particle amount. So we're going to end up getting a 3 by 3 table. Okay, so this would be pivoting it in pivoting the data this way. Okay, so this operation is called pivot wider. Pivot wider. Now in this example, technically, it didn't get any wider. It was started off 3 columns. It ended up being 3 columns. But what we've done is we've basically, it could have ended up wider, and we're basically combining some of the rows, right? Some of these rows. New York large 23, New York small 14 becomes New York 23, 14 with column headings large and small. Okay, so what used to be across several rows, we're pivoting it wider, and we are combining these rows here. Okay, so this is called pivot wider, and what are we doing? We are taking the names of our new columns. The names of our new columns come from the column size, and that's this first argument. The names are coming from size. The new column names are coming from the size column. Values from, okay, the values in the new columns come from the column amount. The values in the new columns come from the column amount. So that's where it's saying values from amount. So this is the operation here. We're pivoting wider, taking the table pollution, we're pivoting it wider. The names are coming from size. The values are coming from the column amount. And this is what we get. Here's the data that we wanted. Okay, and this just says names from is the name of the column that has the names that will become column headers. Values from is the name of the column that has the values. Pivot wider is sensitive to any kind of spelling differences. So let's say I took that original pollution data table, but this first entry is going to be called NYC. So one person, writes New York, another person writes NYC to abbreviate it. Okay, and so if I do pivot wider here, we're going to get one row for each unique value, and so we can't. R doesn't know that these two reference the same location, so it's going to keep these separate. So we're going to end up having what? 4 rows. We're going to end up having 4 rows, right? 1 row for NYC, 1 row for New York. We can combine London, we can combine Beijing, but we're going to have 4 rows here. So when we look up these values, or when R or tidyr tries to do this, NYC, it has a value for large, but it doesn't have a value for small, so we get an NA. New York has a value for small, but it doesn't have something for large, so we get an NA here. So we end up getting 4 rows, 3 columns, and NAs for the values that it couldn't figure out. So that would be pivot wider. Obviously, we don't want this. And so you just kind of have to make sure that when you're going to do a pivot wider operation, that everything is kind of spelled correctly, right? And this includes capitalization and trailing spaces or extra spaces or dots or things like that, right? So some place might abbreviate it USA, and another place might abbreviate U.S.A. or something like that. And some place might have trailing spaces. So you got to kind of process the text to make sure it is correct here. Okay, so this is what we have. One option, if you don't want the NAs, you can say I want to use zeros. I want to fill in with 0 values, or any other number that you want to think of. You can put that in there. Always be careful when picking a fill value. Make sure that if we're going to put in 0, it makes sense to put in 0. I don't think it makes sense to put in 0 in this case. Okay, I'm just showing you how to do it as an example. But if this were the case and you didn't find the number of small particles, I think it's wrong to assume that New York City has 0 particles of air pollution or something like that. It's better to just say it's unknown than it is to just put in a number like 0, which will artificially push it down or something. Even trying to assume that it's the mean, I think that's a very bad assumption, because the mean, who knows what the mean is going to be, and I don't think that's a good idea. So we have that. Okay. Here is another example. The city names are all spelled correctly. New York, New York, London, London, Beijing, Beijing. We're going to have 3 rows when we're done, because we have 3 unique values for here. So this will be fine. What about the columns though? I've got large in caps, small and large in lowercase. So when I say the names for the new columns come from size, it's going to produce 3 new columns. Okay, it's going to combine the cities, but it's going to create 3 new columns. We're going to have a column for all caps large, a column for small, and a column for lowercase large. And it's going to fill in the values here. And so this is what we end up getting. The cities combined fine because they're spelled correctly. But because I had a difference in how we wrote large with capital letters or lowercase letters, we end up getting 3 columns out of that. And then we get NA values for the things that didn't quite fill out. So again, make sure before you do a pivot wider operation, make sure you're your spelling of places and locations and whatever it might be, names and key figures, is consistent. Okay. So, you know, and that can be annoying and tedious, right? So that's something to keep in mind. Okay, last thing to keep in mind is that pivot longer and pivot wider, these are inverse operations. They do the opposite, okay? They do opposite things. So here I have the pollution table and I pivoted it wider and I got this, okay? Now someone else might come along and say, you know what, I actually want to turn it back into this, okay? Or I want this and I want to turn it into something like this. Well, we can do this. So I've saved the results of pivot wider into W. And what do? Well, I can take W and I can pivot it longer. I can take this current table and I can pivot longer. I'm going to pivot the values in the columns large and small. I'm going to take those column headings, those names, and they're going to go into a new column called size. I'm going to take the values in the columns large and small, and they're going to go into a new column called amount. Okay. And so the result of taking this table and pivoting it longer ends up being the exact place where I started, right? So you pivot wider and it goes this way, you pivot longer and you get back what you started. Okay. And then the flip side is true. Here is this table and I can pivot it longer. I can take these columns and combine them into one column called year. The names of these columns, they go into the year column. You can take the values and combine them into a single column count, and I've pivoted it longer. Okay, and I stored this as L. And if I take L, I can pivot it wider. And again, when I pivot it wider, I get back the exact symbol that I started off with. Okay, we're going to take the values in the year column and turn them into names. We're going to take the value, take the values in the count column, and those will be the new values in our cells. And so that's pivot wider. Pivot longer and pivot wider, they are inverse operations. Okay, there is more at the help pages for tidyr. So you have pivoting, and there's more examples of pivoting here. There's another function, part of tidyr, called rectangling. And this is useful when you have kind of nested data, which is maybe more common in JSON format or something like that. JSON and XML data might come in nested. And so this, an example might be something like, let's say you got data on like a movie, and you might have, a director of a movie. Now, a lot of movies just have one director, directed by this person or that person or whatever. But some movies will have multiple directors, right? Some movies will be directed by, a pair of siblings or something like that. Or some films could even have more than two directors. I'd say it's pretty rare, but it's possible, right? There's no rule that says you need to have this exact number of directors. So how do we represent that? Do we have a column for first director and then a column for second director and a column for third director? What if there's a movie with a fourth director? Do we have to have that? And do we have to think of all of these exceptions for how many directors a movie can have? One solution is to just have one column for director, and we will allow each cell to have more than one value. So if a movie has just one director, we put in one name. If a movie has two directors, maybe we put in a list of two names or a vector of two names into that thing. And so how do we deal with that? That's handled with this by what's called rectangling. And you can unnest these things or even nest them together. And that's beyond kind of what we're going to cover in this course. We're not going to get into that, but if it sounds like something that could be useful or helpful to you, then you can consider reading up on it on this page on rectangling. Okay, let me give you your last view quiz answer. Today's last view quiz answer is A. A as in apple. A as in apple. Okay, that's it for today. We will end today's lecture here. Have a great weekend, and we will see you guys on Monday. All right, have a good day.